Hi, I'm Ben the Tutor, and today I want to talk about the definition of the derivative. Okay, this is what calculus is on about. You're gonna, in calculus, do a lot more complicated equation-y type things, but this idea in what is the definition of the derivative is one of the two key ideas for calculus. And if you can do this, this is going to really help you. Okay, so what is a derivative? Okay, so I'm going to begin with a drawing like that. And what mathematicians are interested in is this line there. We call that the tangent, and it has the slope. So as this guy's curving, the slope of this line is changing. That is, whenever I take a flat line and clack it on, I can imagine like a ball or something, I'm tacking on an iron bar. The slope of that iron bar, we call it the instantaneous slope of the function. So wherever that iron bar is touching, that tangent line, that's the slope at that point of the graph. And we want to know what that slope of that tangent line is. And we can find out that, we can know the slope of that guy. And maybe you're asking why. There are so many applications of this idea of the slope and the derivative. Most fields of science, chemistry, biology, physics, economics, psychology, stats, all these things are going to use this concept of slopes and rates of change. Okay, so we have limits. We use the limits. Okay, so I'm going to take this point here and define it as x1. And so the y value there is f of x1. So x1 is the point, and f of x1 is the y value at that point. And I'm going to take another point over here, name it x2, and the y value of that one is f of x2. And I draw a line between these 2 points. Okay, so that line you see is not the same slope as the tangent line. It's a different slope. We call this a secant, the line that cuts through the graph. However, let's just stick with it. So I have here written on the side the slope formula. Perhaps you remember it. It's y2 minus 1, y1 over x2 minus x1. That's the slope of that line. You can just remember, it's rise over run. So the y difference is the rise, the x difference is the run. So I'm going to take these two ideas. The y points are f of x2 minus f of x1 over x2 minus x1. So that's kind of a fancy looking way, but this is just the slope of that secant line. And this way is kind of nice because it doesn't matter what the function is. I have some crazy function, and this will be the slope of these 2 points, no matter what x1 and x2 I choose. Okay, so here's the genius bit of calculus. What we do is we take a limit. We take x2 and run it all the way to x1. So we write the limit as x2 goes to x1. And if I squeeze the secant line and bring it all the way over, then that secant line will become the tangent line. And this formula, this limit, gives me the slope at any point of the graph. Now, what's going to happen in our limit is usually when we just write it like this, we're going to get something that looks like 0 over 0, but we'll do some algebra, and using that algebra, we'll be able to usually get some really cool function come out of it. Okay, so there's a second way of talking about this. There's a second definition of the derivative, but it's the same idea. So I have some function, and I have some x like this. And this is, I call it x, and I call this f of x. Now instead of defining another x, x1, x2, this time I'm going to make a little thing called h. And h is like the difference. It's like a little chalk or a block in the way. And so this x point is x plus h here. That one there. So this x point is just x, and this other one is x plus h. So, and then this f point, the y value is f of x plus h. So x plus h is some x value, some value, and I plug it in, that's the y value. So here the slope, m, is the y's. So y2 is f of x plus h. It's just a y value. And minus f of x, that's a different y value, over x plus h minus x. And in this equation, the x's on the bottom cancel. So I get f of x plus h minus f of x over h. And in this case, what I want to do, instead of running the x's into each other, I imagine h goes to 0. I run h to 0. And as I run h to 0, this secant line is going to turn into this tangent line. So the limit as h goes to 0. And again, you notice there's that h on the bottom, and if h is 0 on the top, then this will be 0 over 0. But again, we do some algebra. As we do the algebra, then we'll see how this thing turns into a function. Okay, so that is the two definitions of the derivative. And using these definitions, we can calculate some derivatives. Okay, that'll be in the next video.